Your computer has no subtractor. It fakes subtraction by flipping every bit and adding 1. Every calculation your computer has ever done could be rebuilt from copies of one part. Not many kinds of part. 1. Two switches in, one lamp out. The lamp stays on for almost everything. Throw both switches up and only then does it go dark. That's the whole part. Here's something strange to carry with you. There is no subtractor inside a computer. Not a small one. None. So how does it ever take anything away? One winter, an American thinker named Charles Peirce worked out that a single operation was enough for all of logic. Then he put the pages in a drawer and never published them. For more than 40 years, those pages sat in that drawer, still labeled to be discarded. They survived by luck. By then, Henry Sheffer had found it again and printed it. One stroke, and all of logic follows. Watch what one wire does. Loop the two inputs together so the gate only ever sees one signal. Now it flips whatever you give it. 0 becomes 1. 1 becomes 0. That's a flipper. One gate. Now flip the answer back. 2 gates and the lamp lights only when both switches are up. That's the gate we call AND. Notice it costs more than the strange one it's made of. Flip both inputs first, and the lamp lights when either switch is up. 3 gates, 4 gates, and it lights only when the switches disagree. That one is about to matter. One column of the machine. One switch up is easy. The lamp says 1. Now both switches up. But a single column has no symbol for 2. What can it possibly write? It does exactly what you did at school. It writes a 0 and throws a 1 to the left. Read the 2 columns across. 1, 0. That is 2. 5 gates built that. Give each column a third input so it can catch a 1 thrown from its right. 9 gates each. Line up 8 of them and the carry falls down the row like dominoes. 7 plus 1 becomes 8. Look at a clock. Going back 3 hours lands you exactly where going forward 9 does. The circle only lets you walk one way, and it doesn't matter at all. 8 switches only count to 255, then roll back to 0. Same circle. So going back 3 is going forward 253, and that is just 3 with every bit flipped, plus 1. Here is 5. Now flip every bit of 3 and add 1. Add the 2 together like ordinary numbers. The 9th bit falls off the end, and what's left is 2. Nothing subtracted anything. The adder just added. So a real chip pulls one lever, flip the second number's wires, and start the row carrying a 1. Same adder, same gates. It just means something different now. Add, and, or disagree, a chip works out all of them at once, every time. Then the selector switch lets exactly 1 through. That switch and that adder are the calculating heart. The computer that flew people to the moon had a processor built from a single kind of gate and nothing else. Its gate was the mirror of ours. Off, unless both inputs are off. Exactly 2 gates in the world can do this. That was the other one. The first processor ever sold on a single chip held 2,300 switches. One Apple chip in 2024 held 28 billion. None of this is the fast way to build a computer. Fast was never the claim. Possible was. 3 lines and you have the arithmetic of every machine you own. Everything above them is only a question of how many copies you're willing to use. The storage in your phone is called NAND flash, named after that same stubborn little part. One gate repeated is enough to count. Next, we make it remember. Thank you for watching. Our small team works tremendously hard on every one of these animations. Following, subscribing, and sharing is what keeps Baucis alive. There is a new video every day. See you tomorrow.